Welcome to All This Math. This is Professor Parker, and today we're going to graph some equations. What kind of equations? We're going to graph some linear equations. There's a whole bunch of different types of equations, but today we're going to deal with a specific type that are linear. Now, how do I know they're linear? Because when you look at the equation, the biggest exponent you see on the variables is a 1. Now, you might be saying, but I don't see a 1 exponent written. Whenever there's no exponent written, it's understood that it's a 1. It's an invisible 1. So that's y to the first power, and this is x to the first power. Now, next question should be, how do I graph this equation? How do I do it? There are different ways we could do it. We have some choices. But what I would recommend is, because this is what's called slope-intercept form, slope-intercept form, let me write that down somewhere. Slope-intercept form, meaning that when you look at this, you can immediately see what the slope is. The slope is the number that's right next to the x, in this case, -6. And you can see the y-intercept, which is the number at the end of the equation, which in this case is 12. When you immediately see that, it's called slope-intercept form. Now, if it's in slope-intercept form, we can use the slope-intercept method of graphing. Whereas you find the y-intercept on the graph, and then you use the slope to get to the next point. The slope is not a point. The slope tells you how to get to the next point. The slope is like a set of directions, right? A set of directions is not your address. The address is where you want to get to or where you already are. The directions tells you how to get there, right? All right, so we want to label some things. So first I want to label the intercept, right? We use the letter B to represent the intercept. Why letter B? I don't know. It just is what it is. That's not really that important. So B is 12. Now, slope. Slope is M. I don't know why it's represented by the letter M neither. It's not important though. M is the coefficient, or the slope is the coefficient of x, which is -6. Now, to make our life easy, we always want to treat this like a fraction. So we want to change -6 to a fraction. How do I change an integer into a fraction? All I do is write a 1 underneath of it. And that works whether it's a positive integer or a negative integer. Just make it into a fraction. Now, why do I do that? This is why I do that, because I like to visualize and understand where am I moving on the graph. Now, because this numerator is a -6, that means I'm going to move down 6 spaces from the y-intercept. And because the denominator is a +1, that means I'm going to move to the right 1 space. And then I'm going to draw my point. All right? Now, let's go ahead to the graph, right? We got a coordinate plane, we got a y-axis, and we got an x-axis. Y-axis, x-axis. All right? Now, the first thing I'm going to plot is my y-intercept, 12. Now, it's the y-intercept. It's not the x-intercept. Don't draw no points on the x-axis. That's not what we're doing here. We're drawing the y-intercept on the y-axis. See that y right there? And this x right here? X is horizontal, y is vertical. All right? Now, I need to find +12 on here. Now, if I start at the origin, that will be 0. I go up, I don't go down. Negative numbers are down here. Positive numbers are up here. So if I go 1, 2, 3, 4, 5, 6, 7, I got a slight problem. And it's a slight problem. It's not nothing that deep. I don't have enough lines in order to count up to 12 by ones. But dig this. I can change my scale. Instead of counting by ones, what if I count by 2s? What if I count by 3s? I don't need to count by 3s. I'm going to just count by 2s. Now, what happens if I count by 2s? Watch this. Now I'm going 0, 2, 4, 6, 8, 10, 12. Now my 12 is right there. You have the ability to change your scale if you ever are in that situation. Also, if you see a multiple choice question where you're given a graph, you got to understand that your scale is not always going to be by ones. You're not always going to be counting by ones. Sometimes you might be counting by 2s, 3s, 4s. You got to pay attention and look at the actual graph. All right. So my y-intercept is at 12. And since I'm counting by 2s, I'm going 2, 4, 6, 8, 10, 12. And I draw my point right there. That's my y-intercept. Right. Now, from the y-intercept, I use my slope to get to my next point. So this -6 right here, it tells me I need to move down 6 spaces. Right. Now, remember, each space is worth 2 though. Don't just count down 1, 2, 3, 4, 5, 6. Don't do that, right? That will give you the incorrect answer. Remember, our scale is by twos. So if I'm going down by 2, that means I'm going 2, 4, 6, right? Now, then I also need to go one space to the right. Now, why am I moving to the right? Because that's a positive 1. If it was a negative, I would go to the left, but it's positive, so I'm going to the right. Now, here's another thing. Your scale on the x-axis doesn't have to be by 2s. You can make it by 2s, but it doesn't have to be by 2s. I'm going to keep my x scale by 1s. My y scale can be its own scale. My x scale can be its own scale. So I'm going to keep my x scale by 1s. So I'm going to go down by 2s on the y-axis, 2, 4, 6, and over 1. See? 1, 2, 3, 4. X-axis is by 1s. Y-axis is by 2s. And then I'm going to draw my line. And then I'm going to be done. So check this out. Try to be fancy. Pull my little ruler out so I could be official. Oh, that ain't cool. There we go. Slide this over here. All right. Now I drew my line. And always put the arrowheads on the ends. All right. Always put the arrowheads on the ends. All right. Now that's my line. All right. Now a couple things I want you to pay attention to. I want you to pay attention to this. This line is going downhill. If we look at this going from left to right, it's going downhill, right? I knew that was going to happen. And this is something I want you to memorize. You will also know that when that's going to happen because your slope is negative. Whenever your slope is negative, your line should be going downhill. Whenever your slope is positive, your line should be going uphill, right? Looking at it from left to right. Understand? All right, so because if you end up drawing a line and your slope is negative, but your line is going uphill, you know you made a mistake somewhere. So you got to go back to the drawing board and find your mistake and then fix it. All right? Now, that's this problem. All right? We graphed this equation. We are done. Now, let me throw another example up here. Finish with that one. Let's put number 2 up here. Number 2 says this equation, 9x plus 3y equals 18. All right? Wait, hold on 1 second. Before I get into that, let me label my equation. Y equals negative 6x plus 12. Yeah, it's like you want to label your lines if you keep them on the graph. You want to label them, right? You know, that's what that is. All right, now this one. This says 9x plus 3y equals 18. All right? That doesn't look like the last example. It's not set up the same way. This is in what's called standard form. What is standard form? Standard form is when you have the x variable and the y variable on the left side of the equal sign, and you have a constant on the right side of the equal sign, right? This is standard form. Now, this is not in slope-intercept form. When the equation is in slope-intercept form, I recommend that you use the slope-intercept method, but this is not in slope-intercept form. So I don't recommend that you use the slope-intercept method. Because this is in standard form, I recommend that you do this. Find intercepts. Find intercepts. Find intercepts. That's another method for graphing a linear equation. Find intercepts. Now, what you need to memorize is that you should use this method when the equation is in standard form. Right? Now, this is just a recommendation. You might not want to do this. You could convert this into slope-intercept form and then use the slope-intercept method if you want to. It's more work, but if you just want to use more time and do more work, that's up to you. But I think you should find the intercepts. Now, next question. How do you find the intercepts? What are the intercepts? First of all, what is an intercept? We already know what the y-intercept is because in the last example, 12 was the y-intercept. The y-intercept is a couple things. It's the point where the line is going to cross the y-axis. The x-intercept is the point where the line is going to cross the x-axis. Also, the y-intercept is the value of y when x is 0. So when the other variable is 0. The x-intercept is the value of x when the y is 0. All right? So keep those things in mind. So that means I need to find an X-intercept and I need to find a Y-intercept. But I'm going to find an X-intercept first just because I like to just move in alphabetical order. No particular reason, though. So the X-intercept, how do I find an X-intercept? I look at the equation and I replace the Y value with a 0. And then I solve for X. I'm going to say it again. How do you find the X-intercept? You look at the equation, replace the Y with a 0, and then solve for X. Check this out. 9X plus 3 times 0 equals 18. 9X plus 3 times 0 equals 18. All I did was I replaced this Y with a 0. That's all I did. Nothing fancy, nothing major. Now I'm going to actually solve for X. First thing I need to do is simplify. I need to do 3 times 0. What is 3 times 0? 3 times 0 is 0. So cross him out. Then I got 9X equals 18. Now, how do I solve for X? I got to get rid of this 9. How do I get rid of this 9? Do the opposite operation from what the 9 is doing right now. 9X means 9 times X. Times means multiplication. What's the opposite of multiplication? Division. So I'm going to divide this by 9, and I'm going to divide this by 9. Boom, boom. 18 divided by 9 is 2. So I know my X-intercept. My X-intercept is positive 2. So as a point, it looks like this. 2, 0. Remember, the definition of an X-intercept is the value of X when Y is 0. Told you that, right? Now, let's do the same thing to find the Y-intercept. Go back to the original equation. Replace the X with a 0 and then solve for Y. So now I got 9 times 0 plus 3Y equals 18. Sorry, that 8 looks a little sloppy, but it's cool. Now, I'm going to solve for Y. First, I need to simplify. I need to do 9 times 0. 9 times 0 is just 0. Now I'm left with 3Y equals 18. Now, how do I solve for Y? I need to get rid of this 3 and isolate the Y. What is the 3 doing? The 3 is being multiplied by Y. This means 3 times Y. In order to get rid of the 3, we have to do the opposite operation. What's the opposite of multiplying? It's division. So we're going to divide by 3 and divide by 3. We got to do it on both sides, just like we did up here, because we got to be balanced. Math is all about balance. Solving equations is all about balance. We have to be balanced. Whatever we do on the left side of the equation, we also have to do on the right side of the equation. Now, 3 divided by 3 becomes 1. So now I have 1Y. 1Y is the same thing as Y, because that tells me how many Y's I have. If I have 1Y, then I just have a Y right there. On the right side, 18 divided by 3. 18 divided by 3 is 6. That's my Y-intercept right there. So as a point, it would look like this, 0, 6. Because with the Y-intercept, that's the value of Y when X is 0. So we got 0, 6. All right. So these are my 2 points. In order to graph a line, we need at minimum 2 points. We got 2 points. So let's do this. I'm gonna plot my X-intercept, which is 2, 0. So I go to the X-axis, start at the origin. I go over 1, 2. I go up 0 spaces. So that's right there. That's my X-intercept. Then for my Y-intercept, I go 0, 6. Now, I'm going to keep it consistent, even though this is a totally different question. This is number 2. This is not number 1. In number 1, my scale on my Y-axis was by 2. I was going by 2s. I'm going to still keep it consistent. I'm going to go by 2s, right? So I go to the origin. I go up 2, 4, 6. Draw my second point. And now I can draw my straight line. Grab your ruler or your straight edge, the edge of your notebook, edge of your textbook, whatever. Right? And now I got 9X plus 3y equals 18. Now with this method, I'm not worried about the slope. I don't care about the slope. I care about the x-intercept and the y-intercept. X-intercept, y-intercept. So when we have an equation that's in standard form, find the x-intercept, find the y-intercept. Plot the 2 points and draw the line. When we have an equation that's in slope-intercept form, identify the slope, identify the y-intercept, and identify the slope, right? Identify the y-intercept, plot the y-intercept on the graph, then use the slope to get to the next point, and then draw the line through those 2 points. All right? Now, I'm going to stop right there. Hope that was helpful. Yeah, basically, so whenever you're given a linear equation, if it's in slope-intercept form, you know what to do. Start with the y-intercept, and then use the slope to get to the second point. Once you got your 2 points, draw your line. If it's given to you in standard form, like this, find the x-intercept, plot that. Find the y-intercept, plot that. Those are your 2 points. Draw a line through your 2 points. All right, hope that was helpful. Thank you for tuning in. Please like, subscribe, share the video, and I'll see you later.